In today's video, we are going to explore the topic of radio waves, discussing what they are, the different types that exist within the category, and most importantly, how each type is used to enable communication across various distances and mediums. Radio waves belong to the electromagnetic spectrum, and they hold the distinction of having the longest wavelengths and the lowest frequencies compared to all other electromagnetic waves. The entire spectrum is referred to as electromagnetic because all of the waves within it are composed of oscillating electric fields and magnetic fields working together. While you do not need to understand the fine details of what that means on a physical level, it is important to know that these waves can be generated using electricity, particularly through the use of an alternating current, since an alternating current consists of charges that are constantly oscillating back and forth. To actually produce radio waves, we use a special device known as a transmitter, which is usually connected to an instrument called an oscilloscope. This oscilloscope is useful because it gives us a visual display of the frequency of the alternating current we are using, allowing us to clearly observe how fast the current is oscillating. The crucial part to grasp here is that the frequency of the alternating current directly determines the frequency of the radio wave that is created, so the electrical signal and the wave that results from it are fundamentally linked. Once we have generated the radio wave using our transmitter, it can be picked up and detected by a second device called a receiver. This receiver absorbs the energy from the wave and converts it back into another alternating current, which is then shown on a separate oscilloscope. The important takeaway here is that the alternating current produced in the receiver has exactly the same frequency as the current we initially used to generate the radio wave, so the information is preserved during transmission. This principle of consistent frequency between sender and receiver gives us the ability to transfer information from one location to another. For instance, if we wanted to send the number 800 to someone else, we could simply generate a wave with a frequency of 800 Hz, and anyone with a properly tuned receiver would be able to identify that frequency and interpret it as the number 800. In doing this, we have successfully communicated a number by encoding it into a wave, and the same approach can be used to transmit much more complex types of data as well, not just basic numbers. This method forms the backbone of many forms of electronic communication used today. Speaking of communication, this is in fact the primary purpose of radio waves in modern technology, and there are three main types that are commonly used for different communication needs. These are long-wave, shortwave, and very shortwave radio waves, and each type behaves differently and is useful in different contexts. Long-wave radio signals can travel immense distances, such as from the city of London all the way to the country of Singapore, without needing to interact with physical objects in between. This impressive capability is possible because long-wave signals are able to diffract, or bend, around the curved surface of the Earth, making them ideal for long-range communication across continents and oceans. Short-wave radio signals can also be used to send messages over long distances, but they do not bend around the Earth like long waves do. Instead, they are reflected off a layer of the Earth's upper atmosphere called the ionosphere, which is electrically charged and allows the signals to bounce repeatedly between the Earth and the atmosphere. This bouncing effect enables the shortwave signals to reach far-off places without needing direct line of sight. Interestingly, shortwave radio is also used in devices like Bluetooth headsets and mobile phones to transmit data over shorter distances, making it quite versatile. Lastly, we have very short radio waves, which are used for television signals and frequency modulation or FM radio. These waves require a direct line of sight between the transmitter and the receiver, which means they cannot bend around obstacles or bounce off the atmosphere like other types can. This explains why your radio signal might suddenly drop when you drive through a tunnel or behind a hill. The structures are physically blocking the wave's path from the transmitter to your car's antenna. Despite this limitation, very short waves are widely used because they can carry high-quality signals for audio and video. To wrap things up, we've now looked at how radio waves are generated using oscillating electric currents, how their frequency plays a vital role in encoding information, and how different types of radio waves are uniquely suited to different communication tasks across the globe. That's everything for this video, and we hope you found it both informative and interesting. If you did, please consider liking the video and subscribing to the channel, and we will see you next time with more helpful explanations.